Okay, hello again. I'm Michael Garry, Head of Content for Atmosphere. Welcome to the End Users Panel. We have two outstanding end user speakers today to talk about their natural refrigerant systems. One is from the supermarket sector and one from the industrial sector. Our first speaker will be Doug Liu of Publix Supermarkets. Now, Doug couldn't be here live, so I recorded a video interview with him a few days ago, which we'll be showing to you shortly. If you have any questions for Doug, you have two options. You can send him an email. We'll be posting his email address in the chat box. It's Doug, DOUG.Milu, M-I-L-U, at Publix, PUBLIX.com. Also, you can just enter your questions in the chat box in the live discussion area with your email address, and we'll make sure he sees those questions. So following Doug's presentation, we will hear a live presentation with Vincent Godin, president of Emblem Cranberry, which is a cranberry processor located in Quebec, Canada. So right now we'll go to Doug Milu's presentation. Please start the video. I'm here with Doug Liu of Publix Supermarkets, based in Lakeland, Florida. Hi, Doug. How are you?
Good, Mike. How are you doing? Good to see you again.
Good to see you. Thanks for joining us at Atmosphere America. So Doug will be discussing Publix's experience with natural refrigerants. Publix is one of the largest supermarket chains in the United States with 1,284 stores in 7 southeastern states. So what Publix does has a big impact on the U.S. marketplace. First, a little bit about Doug. He is the manager of Refrigeration and Energy Program for Publix, has spent 39 years in the supermarket refrigeration industry with Publix, starting in 1982 as a service technician. He's now responsible for refrigerant management and compliance. He does design, input for new store refrigeration architecture, oversees the specs for the refrigeration, HVAC, and energy management equipment, responsible for facilitating proof of concepts on new designs, components, and technology, and oversees commissioning and energy reduction efforts to align with Publix sustainability targets. Okay, so first, Doug, I want to start with transcritical CO2. Can you tell me what Publix has done with this technology and why it has installed transcritical CO2?
Yeah, so first off, the why, Michael, is really looking towards the future, not just with regulations, because that's part of it, but really the bigger picture is becoming more of a sustainable company as we move forward. You know, there's a huge effort here in this country, you know, with sustainable technologies, reducing not just greenhouse gas emissions, but global warming refrigerants as well. So we looked at this about 14 years ago, and as CO2 technology was at the time very popular in Europe, we're starting to see an introduction here in the US. So we said, well, what really is this technology and what is it about? And does it have a place here at Publix? So 11 years ago, we installed our first store in Conyers, Georgia. And our first effort was a simplistic cascade system with low temp CO2 with a 407 topside unit with the heat exchangers. And we learned a lot from that installation, Michael. We've done another store, a couple of stores like that. Then looking at what's next, we chose to move to liquid overfeed systems. We did that for several prototypes for several years. And now we've moved from that system to what we're calling, you know, the transcritical CO2 system, where the entire store is now R744. And really at Publix, that seems to be the way of the future for us. What I would say about that is don't fear it. You know, there's a lot of skepticism in the industry still involving, you know, the technology and technician bases. And, but the reason I say that is because I was skeptical as well when I first started reading about the pressures and some of the different components and some of the nuances, safety protocols that need to take place. But once you do it and you install and start up a system, it's like, okay, well, that really wasn't, that big of a deal. So really for Publix, it's about not only meeting compliance with environmental regulation, it's really about trying to get to a carbon neutral position in the future.
Yeah, that's really terrific. So how many stores now have transcritical CO2?
So we have 3 that are transcritical, but we have 82 stores with some iteration of R744 running in our systems. Predominantly low temp, and then the liquid for the cascade systems, it was low temp CO2. Then we moved to, like I said, the liquid overfeed system, which is low temp DX CO2, as well as 20-degree CO2 liquid pumping throughout the rest of the store for the medium temp cases. And if you're familiar with, the pump glycol systems for medium temp, it's very similar in design. Components obviously are a little different, but it's essentially what we're doing. So the low temp system is a DX refrigerant R744, and medium temp is plus 20 pumped fluid CO2.
Okay, so but it's still entirely CO2. Is that correct? I mean, with that.
Yeah, there's a small topside unit on the liquid overfeed units that's currently 449A. But again, we're graduating from that liquid overfeed system. But the challenge that we've had, quite honestly, Michael, with the liquid overfeed system is we've pared it down to 2 racks. So I have the CO2 rack that manages both low temp DX and the vessel for the plus 20 liquid overfeed. And then we have in conjunction to that, a small topside unit that manages the heat exchangers, for the condensing and the liquid overfeed system. So we've kind of pigeonholed ourselves into a less redundant system, if you will. So what we're doing now is our transcritical systems, our first systems were 2 split suction units. And now what we're doing with our transcritical designs as we move forward, we're breaking that down into 4 units to maintain some redundancy if there is an issue.
Okay. And you have 3 of those transcriticals.
That's correct.
How many of the how many stores with the overfeed CO2 system?
Probably last count, I think it's like 77 or 78.
Oh, okay. Quite a few.
Yeah, and then again, the first generation was the Cascade. We did a handful of those stores to kind of get our feet wet, learn operational knowledge of those systems.
So the pure CO2 then is kind of the latest iteration. Is that correct?
That is correct.
Okay.
And we see that design in more of our prototypes moving forward. We have about 7 different prototypes that are current, which meet customer needs. And we've changed 2 of those designs specific to the transcritical system. We're looking at some uniques now. We have a unique going up where we're multi-level with mixed use. So we're in the middle of residential as well as other retail. Those are a bit of a challenge, but with the CO2 systems, with heat exchangers, gas cooler technology, adiabatic condensing, the systems tend to be a little bit smaller than the large air-cooled equipment that you would traditionally see in retail grocery.
Okay, so that's great. And how many new stores do you typically open each year?
Yeah, great question, Michael. So pre-COVID, we averaged about 52 new stores annually. With that, I would note that there's about 30 of them that are new to the marketplace, where we move into a market where we don't have an existing Publix. And then about 20 of those were replacements of older boxes. So what we find is, Publix has been in business for a while, and through acquisitions, we acquire somebody else's shell, and then we move into it, retrofit it, remodel it. And those shells don't necessarily meet, the box doesn't necessarily meet merchandising strategies for our retail folks. So at some point we have to pull the plug on the actual box and rebuild the box. So again, about 20 of the new stores each year are replacements of older stores. So our net growth is approximately 30 per year. And again, that's pre-COVID. We did okay in 2020. We were able to finish with only a few short of that. However, 2021 has been a dumpster fire. We're going to fall short of that just a bit.
Right. Okay. All right. And so because you operate in the South, and the way you've compensated for the warmer ambience is through adiabatic primarily? Is that basically?
Yeah. So adiabatic gas coolers, our designs are predominantly Hill Phoenix, which, we don't, there's no secrecy there. We work very closely with the folks at Hill Phoenix on not only the layout of the systems for our rooftops, but the design and the components that go into those systems. So working with Baltimore Air Coil, we're using the adiabatic gas coolers, which we find to be very efficient for this technology.
Okay. And sufficiently so that you don't think you would need additional technologies like, say, ejectors or parallel compression or something like that?
So ejector technology is available. I also saw that there was a pressure exchanger technology. That was very intriguing, and I'd like to learn a little bit more about that. And one of our roles here is understanding innovation within the technology that we're currently using, as well as new technology bringing into the refrigeration architecture. So again, what we'll do is, we'll reach out to that company, get some more information, and probably do a proof of concept and look at the efficacy of that particular system and what it can result in bringing.
Yeah, that is an exciting new technology, energy recovery. We've covered that, and we have some articles on that. Okay, but so with adiabatic, how would you compare the energy consumption of these, say, three transcritical CO2s, or even the pump one that you mentioned? The DX, the Overfeed, compared to a DX HFC.
Yeah, so I'll start with the first iteration, and one of the reasons that we moved away from our first iteration, which again was low temp CO2 with a topside unit of 407 at the time, and that topside unit has the evaporator condenser, if you will, for the low temp unit. So transferring the condensing from CO2 to my medium temp rack through my energy curve, kind of off the chart, if you will. So that rack had to be able to accommodate not only the medium temp load in the store, which is usually a little bit higher than low temp anyway. Now I've added the condensing load for rack 1 to that. So my energy profile in, say, for a 45,000 square foot store was about 15% higher than any other traditional air-cooled traditional HFC store that we had of its type. So that then we said, okay, well, we've done it. We understand the technology. We've got operational experience. It took us a few years to kind of figure out what we were doing, how to handle it, supply chain for CO2 when there's an issue, working with the gas suppliers. We ironed out all those details, and then we said, okay, well, what's next? How do we get closer to parity? And again, the majority of our stores average around 45,000 square foot store. Quite honestly, they'll go from, I think our smallest store is about 16,000 square foot. We don't have many of those, all the way up to 65, almost 70,000 square foot in some of the acquisitions. But our core square footage averages right around 45,000 square foot. So that's kind of our benchmark to look at energy parity in our systems moving forward. So with the liquid overfeed system, we were able to get a lot closer to that. because you're not having to exchange all of that because the CO2 rack is running both the low temp DX as well as a lot smaller pumps for the liquid overfeed. So now when you move to the transcritical, now you're at much higher pressures. So our energy consumption on that for an average 45,000 square foot store is now again back to a certain percentage higher, maybe 12 to 14% higher than what we'd like to see. However, we have one store that our first transcritical store in Longwood, Florida, which is just north of Orlando here in Central Florida. We're working with our equipment manufacturers and our control supplier to optimize that system in a way, Michael, that will get us a lot closer to parity. So there's VFD technology as well as the adiabatic gas coolers, and we're constantly going in and massaging that system to try and get it as close to parity as we can. Not quite there yet, but I think with some of this other innovation that we're seeing surrounding our 744 and retail grocery, I think we're going to get there relatively soon.
That's great. That's great. And and you were able to get your technicians over the hump when it came to CO2. I guess they probably done that a while back.
Yeah. Again, I mentioned earlier not to fear it, and again, there can be a lot of skepticism when you're talking about change, especially when you have an established contractor base and you throw in a new technology. Change can be good, and I'm not saying it isn't, but it can also be scary. So, we fear what we don't know. And, once you get over the hurdle of understanding some of the nuances with working with our 744, the pressure differences, typical HFCs, you may have 1 or 2 pounds of change per every 1 degree of an HFC, whereas our 744, you're at 6.5, almost 7 pounds of change for 1 degree of our 744. So that then tips the scales when it comes to, the pressure variance you see. Well, what the industry has done, the case and equipment manufacturers, they've worked on safety protocols for, pressure relief valves. We know not to isolate the refrigerant within a system at any time. You always allow it for an escape route back to the suction side. So there are some nuances with the system that the technicians had to learn. But Michael, once they learned it, it's like, oh, okay, yeah, this is really not that big of a deal. Yeah. So I think for us, still our biggest challenge, and I'm sure it's with others that have moved down the path of naturals, is the supply of our 744. So us that are used to HFCs in the industry, I could call any of my suppliers local here, and I could get gas delivered 24/7, 365 if I needed it. That's not necessarily the case with the gas suppliers. So we're trying to work with some of the larger companies that are supplying the refrigerant grade of our 744 and kind of bring them along to our side of the industry, if you will, to help align with that. Obviously the bottles are a lot different. They're a lot heavier. A large bottle only contains 50 pounds. So when I charge a liquid overfeed system that's got 800 pounds of liquid in it, I've got 3 pallets of these very heavy bottles that the techs have to move around. So with that notwithstanding, those are some of the difficulties in implementing a natural solution, but they're not so arduous that you can't overcome them and make plans to deal with them.
That's great. Yeah. I think the industry's learned a lot in the last few years with all the implementation that we've seen. Now, in terms of existing stores, you mentioned that there are 2 expansions that you're planning next year using the Advancer Flex, or is it the Advancer Flex Mini or the Advancer Flex? It's the
Advancer Flex. We have a training center where we're developing now here in Lakeland for tech training as well as our internal folks, which will have a Flex Mini, because obviously it's a scaled down version of what we would see in the retail store.
Okay, but for these 2 new expansions, it's the Flex.
Flex, that's correct.
And it's going to handle a couple of lineups. Where are these stores? These two stores?
So that's the thing. They haven't been plotted yet, but we have the designs that we're working on. So once we plot them, then we can let you know whether
Will these be for medium or low temp?
low temp.
Low temp. Okay. And is this the first time that you've done transcritical for existing stores?
Yes, it will be. Actually, these aren't existing stores. These are new stores. That's why I said they haven't been plotted yet. So they're working out deals with the developers on the areas. And once
these are new stores using Flex. So first time using the Flex. So these are smaller stores.
That's correct.
Okay.
And again, with moving towards from the traditional 2-rack transcritical systems that we have in the 3 stores that are currently up and running, we're moving to 4 racks, which lends itself to the CO2 Flex unit. They're a lot smaller capacity from BTU.
But for existing stores, do you think you could use Transcritical CO2, one of the, maybe the Flex or some other version?
Yes, we can in where we're doing expansions, and those are a little further out, only because working with the developer and the landlord that's in those stores, expanding a store footprint, there's a lot of stuff that has to take place as far as negotiations with landlords. Typically, when we do that, the landlord is required to upgrade the center. So there's a lot of negotiations that go into that. But as we expand stores, it's a lot easier to set new equipment on the roof, like a CO2 Flex unit, install that side of the store behind visqueen or panels, if you will, start that system, and then overnight open that system to where the customers just see a new area basically the following day. But those we're still working out the details on, Michael. But yes, the CO2 Flex would lend itself in those scenarios.
Okay, but for existing stores where you need to replace old cases or an old rack, you haven't really come up with a particular scenario, or could it include CO2?
It could. We haven't worked out the logistics yet.
Last question is about R290. You've said that it's now standard for new stores for self-contained cases where you have those.
That is correct.
And is that also the case with existing stores where you need to replace a plug-in?
Yes, sir. Obviously, depending upon cabinet size, but those, because of the charge limit, any of those cabinet sizes that we replace in existing stores will be replaced with R290. Any new store moving forward, depending upon cabinet size, like you see the beverage coolers at the registers, or as you're walking out, Coke or PepsiCo have their machines there. Those are all R290. The self-contained in the lobby, those are all R290 now. The fresh pet, the organic offerings for down the pet aisle, where those units are now R290. So again, it just depends on currently today the cabinet size, but we really believe that R290 has kind of won that small cabinet format. True is right there with the rest of them, leading the way in that technology and providing good training to technicians when they're working on their equipment. So hats off to them. RSES has good training now available for R290. So so that R290, R600 isobutane. We're starting to see that there's one company that we get some equipment overseas that's got 513. But other than that, most everything that we have in small cabinet is going to R290.
So the charge size is going up in the States. UL has approved an increase to 300 and 500 grams. Do you see that expanding your ability to use R290 cases in larger cases?
For Publix, I would say yes, but it really is now up to the equipment manufacturers to, design, build, and offer those larger cabinets. But yes, at some point, I see that happening.
Do you see a scenario where you could start, putting in R290 cases to replace old cases, that were previously remote, or even, complete lineups, or even a complete store, if they have?
I can't tell you that we would look at that just yet. So it's my understanding that the charge limit is based on self-contained equipment that's in an occupied space. I don't think that there's the same restrictions on condensing units that are relegated to the roof that is not occupied by people. I don't know that we would do that just yet. I've not seen a lot of that technology. I know there's been a couple of manufacturers here. I know that Carnot had a system with a large propane topside unit. I've not seen it. So really it's about operational experience for us before we move to another refrigeration architecture.
All right, Doug. Well, it's been great learning about your natural refrigerant activities. They're quite extensive and impressive. And we really thank you for joining us here at the conference.
All right, Michael, thank you. Appreciate it. Y'all have a great day.
Thank you. Okay. I want to thank Doug Liu for his presentation. Again, questions can be emailed directly to Doug. His email address is in the chat box. It's doug.liu@publix.com. I'm going to move on now to our next speaker, Vincent Godin, who is also using CO2 refrigeration, but on a much larger scale. Again, questions can be directed to Vincent in the live discussion box. A little bit about Vincent. He is an engineer and a Cranberry producer, one of the founders and the president of Emblem Cranberry, based in St. Eulalie, Quebec, Canada. Emblem Cranberry distributes frozen cranberries and wild blueberries in over 25 countries. It handles over 10% of the Quebec cranberry crop, and its rapid expansion in the wild blueberry industry has required investments in CO2 technology. Emblem operates 230,000 square foot facility with 3 production lines, including one that can freeze up to 25,000 pounds per hour of wild blueberries. And with that, I'll turn the stage over to Vincent.
Yes, hello everyone. I'll just share my presentation. So thank you for the introduction, Michael. Yeah, I'm gonna go back to the top. So Emblem Cranberry, yeah, we started in 2016. Like Michael said, we handle about 10% of Quebec crop, and we had a fast growth. So we're a producer, conditioner, and distributor of cranberries and wild blueberries in over 25 countries. There you go. So phase 1 was in 2016. Phase 2 was in 2017, and phase 3. And I will all describe the different phases in the next few slides. So phase 3 was this year. So that's pretty much what our facility looks like. It was still under construction this summer. So the phase 1 of the facility included 3 freezers at 0 Fahrenheit, 1 production area at 40 Fahrenheit, 1 cooler at 40 Fahrenheit, and docks area. It was powered with 2 CO2 refrigeration racks, and it included subcooling. So the process of cranberries at harvest, we bring them in, we clean them, we put them in bins like you see in the photo right there. And the work of freezing the cranberry, unlike any other IQF technology, is really blast frozen in the freezer. It takes about 45 to 60 days to reach that 0 Fahrenheit in the heart of each bins. The phase 2 was an expansion in 2017. It included a blast freezer mostly that worked in blast for the month of October to December, the time it takes to actually reach 0 F in the heart of each bin. And after that, it acts pretty much as a holding freezer for the rest of the year. For this one, it included 2 racks of CO2 and subcooling plus an adiabatic gas cooler. The phase 3 that was this year included an IQF tunnel with a suction temperature of -40 F, and that could freeze up. Well, it's written 20,000, but we reached 25,000 pounds of wild blueberry per hour this year. It included also a makeup air to change the air in the production room with 6,000 CFM that was cooled with CO2. And on the blueberry production, it included also a hydro cooling of the blueberries before they enter the IQF tunnel with CO2. Actually, that's the photo that you see there with CO2 running in these pipes that was cooling the water. So the IQF tunnel, you have a picture of it right there. That was supplied by one supplier in the US called AFE. And you get another picture of the rest of the line. In every part of our facility, we have docks that are cooled at 40 degrees. And all of the floors of the slabs in the docks and in the production zones have radiant floor heating that is glycol that circulates, and the heat from the glycol is all transferred from the CO2 racks. When we look at the freezer, the blast freezers, under the slab there's a glycol network that circulates to prevent an ice building in the sand, in the material below the freezer, so that prevents really the building from moving. So the freezer, the phase 3 of this year included also one blast freezer to lower the temperature of the blueberries that were coming out from the IQF tunnel to -13 F, and it included also a blast freezer to blast freeze cranberries and to hold at 0 degrees F. We have a freezing capacity of over 55 million pounds of cranberries and an additional 16 million pounds of blueberries freezing holding capacity also. So all of our systems includes a pumped CO2 technology. So we have 9 transcritical and subcritical CO2 racks or package. And the total cooling and freezing capacity is around 1,500 tons of refrigeration with suction temperature that are ranging from -20 to -40 F, depending on is it for cranberries or for blueberries. The difference in temperature at which we want to hold the cranberries or the blueberries, it depends on well, blueberries will be held at lower temperature of -13 F because they have more sugar content that will cause them to leak if they're not holded at cold enough. All of the controls and the program are microthermo. It is on computers. It's pretty efficient to play with. So it does the complete refrigeration, the HVAC, the electrical management, the data logging. and they control all of the rack, the gas cooler, and all the probes are connected to it. That's a little show of the control panel and the micro thermo screen on the computer that we see. So I talked a little bit about it earlier. All of our facility includes heat recovery from the racks. So we get the heat out of the CO2. We inject it into a glycol network that will do the heating of the radiant floors. They will do the heating of the under slab in the freezer. They will also do the defrost on the evaporators in the blast freezer, and they will also do the defrost of the coils in the IQF tunnel. So we practically don't have to pay anything in heat because of the heat recovery solution that we have with our racks. Oh, yeah, and I forgot to mention, we have a lot of cleaning to do in the production line, and with especially wild blueberries, cleaning is way more efficient with warm water or hot water. So we do warm that water with heat recovery from the racks also. After that, little word on the evaporators. All of the system is pumped CO2 instead of a DX. There are significant performance and savings. In the phase 3, we also invested into high efficiency fans with VFD so that they don't run at 100% capacity at all time when it's not needed. The coils all have also epoxy fins to make sure that the cranberries and wild blueberries are quite acidic. So we did cover these fins to make sure that they will last for a long time and they would not corrode. After that, that's a little picture of the installation in the freezers. So we pile the bins one onto another, and we have a passway to have the evaporators more easily accessible. So all of the maintenance is facilitated with these passageways. Yeah, a little pictures of the. We also have some in phase 2 and in phase 3 some adiabatic technology, where the previous speaker talked a little bit about it, but that's a diagram of the how it works. So it uses water to actually condensate the CO2 more efficiently. So that's another explanation of the adiabatic technology. It's HydroBlue Transcritical gas cooler. They're high efficiency fans with variable speed control. They're all stainless steel, obviously, and well, we try to minimize the water consumption also with these. There are external subcooler and parallel compressions. I'm not that much knowledgeable in, so I'll skip that part. And based on the calculation that Zero C, our supplier, did, we expect to save about 20 to 30% savings on energy. But the only facility that we have is all CO2. We don't have any comparison point on that. But what I can tell you is that we have a 100 kilowatt furnace to heat the building when the compressor doesn't generate enough heat. And in 6 years we've been operating, the furnace started only once for about a day. in a very cold night, and that was about it. So we have virtually no heating cost for that facility. So that's a picture of one of the racks with the CO2 tank. Another picture of the coils of the IQF tunnel, where you see the CO2 pipings that are horizontal loops, and the glycol pipings that are that are vertical for the defrost of the coils. That's a picture of the adiabatic condenser on the roof. And one last picture of our facility. So thank you very much for inviting me. And Michael, I think you have some questions.
Yes. Okay. Thank you so much, Vincent. Really appreciate your presentation. A very interesting system, very large system, one of the largest CO2 systems that we know of, actually, in North America. Okay, I encourage everyone who has any questions for Vincent to enter those in the live discussion box under questions. I have some questions for Vincent. First of all, I just want to be clear, Vincent, what you've described to us today is a new facility, correct?
It's a brand new facility. So phase one was built in 2016, phase two in 2017, and the last phase with the IQF tunnel was this year, 2021.
How has your business been in operation doing this prior to 2016? Did you have a different?
No. So we went from the start with the CO2 system. Our reflection in comparison to ammonia that are more widely used in our area was that there's a reduced risk in comparison to ammonia system. It's all food products, so an ammonia leak could be more damageable than a CO2 leak. So that was one of the main reason we went for the CO2 system. The other thing is that synthetic refrigerant are still used maybe on a smaller scale unit, but there were some very interesting grants from the government of Quebec for the usage of these CO2 systems that are less damaging than the synthetic refrigerant.
Oh, okay, that's good to hear that the government supported that project.
Yeah.
So prior to that, you weren't doing this kind of processing, is that correct?
That's correct.
You had a different role. Your business did some other things, is that correct?
Emblem started in 2016, so we didn't have any experience before that.
This is your first go around with this. Okay, got it. Yeah, so you got all of your equipment from Zero C in Canada. 9 CO2 racks, I believe 6 were transcritical, medium temperature, 3 subcritical, low temperature, and they're all pumped, interestingly, not DX. I mean, it was sort of used to, especially in supermarkets, for these CO2 systems to be DX. At least, yeah. In this case, it's a pumped system. So, but you said it has certain advantages.
Yeah, so I'm not an expert in refrigeration, but our supplier explained to us the pump system allows us to have more tonnage of refrigeration with less horsepower or less kilowatt of compressors, because they can play with they can play with some parameters and that make them more efficient than the DX system. So far, Michael, the system has worked quite well for us. There was some maintenance, but normal maintenance, a few compressors that we had to change. There were a few CO2 leaks that we ended up finding that were mainly in the heat exchangers in between CO2 and glycol. And on the performance side, it was aligned with our expectations. So Zero delivered. Our expectations were in terms of duration, in between the moment we get the fruits in and the moment where the bins, the center of the bins reach that 0 degrees F. And in terms of capacity of the IQF tunnel, we even went over the capacity that we thought we would have.
That's great. So the system has really worked well for you, and it's a very 1,500 tons of refrigeration is a really large amount of capacity. I think it is one of the largest that I've heard of. Is that your understanding?
Yeah, well, that's what that's what we were told by Zero. Yeah, and there's also the fact that it's 150 tons, and that the majority of it is low and extra low temperature at saturated suction temperature of -40, -32, -20, and so on. Yeah.
Right. Yeah. And so, and in terms of energy savings, have you tracked? Well, you said you don't have a direct comparison, but your expectation is that it is a more efficient system than
we think so. We think so. And there's also a particularity with the system that helps us to actually save on our electric bills. In Quebec, there's a program by our electricity provider, Hydro-Quebec, where it allows us to be paid when we reduce our electricity consumption during the peak electricity demand in the winter. So the system is designed where we can stop the compressors and leaving only one compressor per rack running during these 3 hours of peak demand. And with the microthermal program, you can shut down the temperature, well, not the temperature, the compressors on to reduce our capacity and be paid for it.
And so you're able to do that without any drop in performance or anything like that during that?
Well, when we do that, we're actually in holding of the freezer. So there's a small change in temperature in the freezer, but we're thinking about not even a decimal of Fahrenheit during these 3 hours because of the insulation, the huge mass of frozen product that are in the
Right.
freezers.
Okay, well, we have a few more minutes, and anybody who wants to throw a question Vincent's way can do so in the discussion, in the live discussion box. What about maintenance, Vincent? This is a big system. Do you have the technicians in your area who can work on CO2 systems?
So the supplier we have a contract, a maintenance contract with the supplier Zero C. They work with technicians on the road, but they can also access the microthermal program via an FTP connection. But like you said, Michael, it's a complex system. So one of the biggest challenge we've had so far is to get our guys to understand the details of the system. It's still a challenge because we haven't reached that completely. For example, when we bring in the cranberries in the freezer, we bring in a lot of humidity with it. And we have to adjust the number of defrost per evaporators per day. We have to start very high in terms of number of defrost per evaporators, and we have to slowly bring it down when the humidity, the biggest block of humidity is out.
Okay.
So there's still some challenges, and it's not a perfect science. There's always some tries, yeah.
All right, well, thank you very much, Vincent. This has been really fascinating. Good luck with all the cranberries and blueberries, which are delicious fruits, of course. And we really appreciate your time here. The next session coming up right away is on policy and standards with EPA, CARB, and the U.S. Climate Alliance. So thank you and have a nice day.
Thank you.